Welcome to our course on Hadoop administration. So let me give an introduction to the course which we cover and let me talk you about what topics we touch upon and what all contents are covered in our Hadoop administration course. So when we say covered in Hadoop administration course, it means we are doing hands-on demos on them, right? So it's not just about the theory part, because Hadoop administration course is more about hands-on. So once again, a very warm welcome to all the participants for attending this session from LearnTech. A welcome to all. So let's begin and see what things we will be covering and what is the normal course flow. So how it works out? The very first and the most important thing is live interactive classes with your instructor. So what does it mean? It will not be any pre-recorded sessions. So all your interactions will be live with your instructor. So you can ask questions, all your doubts can be cleared at that moment or even after that, let's say through an email or through a support channel. All the classes, they are recorded so that you can watch them at your own convenience. So sometimes it might happen that you are not able to attend some session, or it is very difficult to grasp everything in just one sitting. So at your own convenience, you can go back, watch the class recording and clear your concepts. We have support for the participants through email and phone. Let's say any of the logistic issues they have, let's say they're not able to log into session, any documents they need, any technical issues they might have faced, let's say setting up a cluster at home. So all these things you can address to the support team. Then each of our module has quizzes and assignment. So end of each module, when I say module, it means at the end of each week you will have quizzes and assignments, which will give you kind of an idea into what kind of questions might come in, let's say Cloudera exam. So I'm not saying by just doing the quizzes you will be able to clear your Cloudera exam, but they will be kind of testing your knowledge on the concepts which you have learned in the module. And similarly, you will have an assignment based on that particular module. At the end of the course, you will be given a project to work on. So project will be more of hands-on kind of thing. It will not be just theoretical. So you might be asked, for example, let's say set up a cluster with these parameters. This should be the replication, this should be the block size, and you will be given some data set to work upon. And for evaluation and grading, you have to submit your config files. So accordingly, your grading will be done. So what things we cover, although Hadoop is a very, very vast topic, right? But we try to touch upon all the major things which you need to know being a Hadoop admin, right? Let's say you join a organization as Hadoop admin. So what things you will be doing in your day-to-day activities. So all those things we will be covering in this course. So our course is divided into 8 modules. So in module 1, we will be starting with, let's say, what is big data, right? So before starting on with Hadoop, first of all, we should understand why we need Hadoop in the very first place. Is Hadoop the only platform? No, obviously not. There has been a lot of platforms prior to Hadoop. Distributed computing has been there, parallel computing has been there, right? The MPI stacks. But why Hadoop? So we will understand that. So we'll build up a use case for Hadoop. Then we will look into the introduction of Hadoop. What is Hadoop? What are its important components? And some of the technical details of Hadoop. Then in module 2, we will go deep dive. We will set up a Hadoop cluster. We will look at the parameters like replication, what is a block size, how a replication is impacted, and which node plays a role when doing a replication. Is it the name node, data node, or the source node where you do a copy. In module 3, we will be talking about our cluster planning. Let's say somebody says, I want a Hadoop cluster for my project and my data is 1 terabyte of data, raw data. So I need to plan, okay, 1 terabyte of data. Do I have to take care of replication? What will be the retention? What will be the processing needed? How many mappers or reducer slots I need to assign? So we will talk about cluster planning, like what will be the hardware for name node? What will be the hardware for data node? What are the software requirements? How will be your network interconnects, right? All those things. And we will understand the map reduce also, like when you submit a job, what happens at the back end. So this is a Hadoop admin course. So we will not be going into the code, the Java code, but we will be looking at how job tracker, task tracker communicate and how the job execution flow happens. Then in module 4, we will be looking at what are day-to-day activities a Hadoop administrator performs. For example, he might be doing a backup, a patching, Hadoop upgrades, addition or removal of data nodes, means he might be scaling the cluster. Some node goes bad, how you will replace hardware, let's say how you add or remove a disk space, right? All those kind of activities. How you create quotas, right? I cannot say, let's say my total Hadoop is having 100 nodes and 100 nodes account to 1 petabyte of storage. So I cannot say just one user can use 1 petabyte. So I have to put up restrictions. So there will be quotas, there will be users, how you commission and decommission a node, right? All those things we'll be looking at. So we'll be looking at cluster maintenance. In module 5, we will be looking at our new Hadoop platform, which is Hadoop 2.0. So we say 2.x because any versions after Hadoop 2. So we will look at what are the new features which has been added, like high availability, federation, what is the new platform like Yarn. So we'll be talking about how you set up a cluster for that. In module 6, we will be talking about the Yarn, which is kind of a new platform for MapReduce, yet another resource negotiator. So we'll be looking at how it is better than the old MapReduce and what are the new daemons or new config files which have come up. We will also look into high availability and federation, what are they. So when I say we will also look into, so it does not mean theoretically. We will be doing demos on all those things, right? We will be setting up high availability, we will be setting up Hadoop 1.x cluster, 2.x clusters, we'll be doing failovers, right? All those things. In module 7, we will be looking at pig configuration and use cases. For example, use case might be you have to process Apache web server logs. So we'll see how we can do that using pig on Hadoop. Then we will also look at Hive and HBase. Although they are itself very vast topics, Hive, HBase itself, they are very vast, but we will be touching upon from a Hadoop admin perspective, because if you are a Hadoop admin, it is your responsibility to install Hive, HBase, maintain it, upgrade it, patch it, take care of any failures. So we'll be setting up HBase cluster as well. In our module 8, we'll be talking about Scoop, right, which is kind of used for importing data from RDBMS, importing or exporting. And we will look at some examples. Then we will look at Hadoop performance tuning. So it is not just about setting up your cluster, just not about setting up a name node or a data node. You have to tune it so that it performs the optimal way. So in the last, we will also give you a project which you have to submit for your grading. So this is what the contents will be covering. So let me give you a quick overview of, or I can say a feel of how the course is or what the course flow will be. So before starting or directly jumping into what Hadoop is, first of all, we should understand why Hadoop is needed. So for that, I have to understand big data, right? So big data is a very well-known term nowadays. Everyone is talking about big data. So what is big data? So the very first thing which comes to our mind is the size of data when somebody says big data. So big data is data sets that are too large and complex to manipulate with our standard tools or methods, right? Manipulate or interrogate. So what does it mean? It might be very easy for me to store, let's say, 1 petabyte of data, but can I quickly process it? Can I quickly extract some useful information out of it? That is the challenge. So big data is a popular term used to describe the exponential growth and the availability of data, both structured and unstructured, right? So nowadays we see an exponential growth happening. So we have to address all these things. So now the question comes, where all this data is coming from? We have enterprise systems which are generating lots of data. Every day the number of servers, they are growing at a rapid rate. You have automation in place. You do not need to sit in front of a system to generate data. You can write scripts. You can have, let's say, your CI tools in place, which might trigger your jobs, which might automate your tasks and generate a lot of data. For example, your Apache logs. You might have a web server farm of 2500 nodes, right, which is serving your front-end traffic. So all the logs which are generated, you need to collect them, process them. More and more devices are connecting to the internet. So when we say more and more devices are connecting to the internet, the very first thing which comes to our mind is we say mobile devices. So it is not just about, let's say, iPhones or iPads or laptops. It could be any of your telemetric devices. For example, your health monitors, any wristwatch you might be wearing on your arm. All these are sending data to the cloud. So the data which is coming to the internet or any of your data center, it's growing exponentially. Data might be weather forecasting data, right? Lot of sensors there. It might be any of your flight data. For example, British Airways, they are using big data and Hadoop platform for doing analytics. Analytics of what? What is the load carrying capacity of their planes? They have a lot of sensors. For example, sensors might be for weather. What is the cargo load carrying capacity? What is the fuel capacity? What is the round trip time? How many passengers are there? Right? A lot of things you need to keep track of. So you need to do analytics. Another important thing is stock exchange. Let's say you want to bid on a stock. I cannot just blindly go and say, okay, I will take this X share, invest money into that. I cannot do that. I have to study its behavior over a certain period of time. So how I can do that? Only if I have data. And that data could quickly give me an answer. So it is not that, okay, I want to bid on a share, but it is giving me an answer after 1 week. No. So we need a platform which can work on large data, quickly extract it, give us a meaningful information, and it's also redundant, fault tolerant, and easily scalable. So we have all these challenges at our hand. So Hadoop is growing exponentially. So over the last few years, you will see your enterprise data, voice over IP, your social media, your sensors. Sensors could be any sensors, weather sensors, or any of your projects. For example, it can be an Hadron Collider sitting in somewhere in Geneva. It generates petabytes of data in few seconds. You might be capturing data for SETI, right, which is search for extraterritorial intelligence, or you might be monitoring the night sky to look for the patterns of stars, right? So the data is growing exponentially. So there are n number of use cases for you to work. So we need a platform which can address all those things. So currently, when we say big data, the very first thing which comes to our mind is size of data. But it is not just about size of data. So there is a very interesting definition which is called 3 V's of big data. So this definition originally came from IBM. So where we say 3 V's. What are 3 V's? Volume, velocity, and variety. Volume means terabytes of data. I may have records, I may have transactions, I may have files, I may have tables. Velocity could be, it could be real time, it could be streams, it can be batch jobs, it could be a different rate of data, means at what frequency data flows into my system. That is also a challenge. I can easily set up, let's say, 100 node cluster, but on that cluster I may have a data feed every minute, every hour, every day, every 6 months, right? So there can be n number of use cases, so I have to take care of that. Third thing, variety. I may have structured data, unstructured data, means I can have images, I can have video, I can have text data. Data could be n number of, right? It can be simple file, it can be your binary files. How will I process them on a platform? So we have all these challenges. So all these challenges, we need a platform. So Hadoop is a platform which could address all these things. Why it can address all those things? This is what we will see in our course. What features Hadoop has. So the very first thing which we talk about when we say Hadoop is, we think that it is a tool. First of all, Hadoop is not a tool. It is a framework. It is a framework that allows for the distributing processing of large data sets across cluster of commodity hardware, right? So you do not need those expensive enterprise kind of mainframe systems or dome servers, right? You can work them on decent hardware. So obviously when I say commodity hardware, it does not mean I can run them on desktop, right? So it does not mean cheap hardware. You will use a cheap hardware in your production server. So this picture is taken from Yahoo data center, sources from Yahoo. So you need a decent hardware. What does it mean? You need racks so you can better manage your space. You need cooling so that it can keep your systems cooled. You need power supply units. You need backups. You need structural cabling. You need switches, routers. You need all those things. So it is not that you will just pick up a desktop, put up a name node and start pumping in your production data, right? It is not. So we have to look at hardware also. How will be the network interconnects? So you have to design your data center. Currently there are a lot of companies who are using Hadoop. Whether they are startups, whether they are banks are using Hadoop at a very large scale. For example, JP Morgan, Morgan Stanley, Bank of America, they are using Hadoop platform for doing fraud detections, like any transaction anomalies or any kind of credit scoring. So the scope of Hadoop is growing up because the data which is pumping into a system is growing at a very, very rapid rate. So now the major companies which are into Hadoop are Yahoo, Google, these two main companies, right? So there are other many big companies like Facebook, IBM and all, but Yahoo and Google has a very important role to play in the development of Hadoop, in the creation of Hadoop, right? So we will see along our course that how Hadoop came into picture, how Google's two paper on GFS and MapReduce played a role in the development of Hadoop. IBM has their own Hadoop version. For example, Big Insights. Microsoft uses HD Insights. We have different vendors. For example, Cloudera, Hortonworks, MapR, Pivotal has their own Hadoop version. Intel also has their own Hadoop versions, right? But they are based on a common core base platform, which is Hadoop, which is available under Apache Foundation license, right? It is an open source, purely open source. So the main components of Hadoop are, right? So the main aim of this session is just to give you an insight. So I'm not going into detail. So we go into detail in our course about each and everything. So I'm just kind of giving you an overview of what things we cover in our course and what kind of logistics we have, right? What things we use. So it will give you a fair enough of good idea about the course content. So when we say Hadoop, Hadoop has core components. Although Hadoop is a framework, I can plug in lot of things. I can plug in Hive, I can plug in HBase, I can plug in Mahout, I can plug in Uzi, I can plug in Pig, lot of things, right? But the two main base core lines are the file system, where I will be actually storing the data, which is storage, which we called HDFS, Hadoop Distributed File System. Second is the brain of Hadoop, right? It's not just about putting data. Once I have uploaded data, I should be able to work on that data. So which we do by using MapReduce. So MapReduce is a programming model which is based on key value pairs. So we'll look into all these details in our course. HDFS also has a lot of details, in-depth details. For example, unlike our traditional systems, let's say a Linux or a Windows, where we create a file system on a hard drive, let's say ext3, my metadata and the actual data both sit on the same system, means same hard drive. I will have an MBR, in that I will have a partition table, right? It will point me to a file allocation table, in the case of Linux, inode structure, which will say, okay, this file1.txt has this owner, these permissions, and these are the blocks mapped to it. But in the case of Hadoop, it works in master slave mode. What does it mean? I will have a master which is called name node, and slave is called data node. All my metadata will sit on my master name node, and all my actual data will sit on data node. So the architecture will be something like this. I will have one system which will be a master, which will store my metadata. It will say, okay, file name is, let's say, data. It will say, okay, file name is data. It is replicated 3 times, but it is on which blocks. So metadata will always sit in the memory of the name node. It will never be swapped out. So what types of metadata we have? It will list the files, list of blocks mapped to a file, then the mapping between blocks and data nodes, and file attributes. Everything sits in our master, but the actual data sits on the data node. So all this has lot of details, like what can be the size of metadata, what is an object size, how big my cluster could be, right? All those things are decided by these parameters. So we will look at all this detail in our course. So let me give you a quick demo on Hadoop cluster. So it will give you an idea what I'm talking about. So currently, let's say I have 4 systems here, 4 virtual machines which are running CentOS. I have my name node which is running on NN1. If I do JPS, it shows name node is running, and I have 3 data nodes, DN1, DN2, DN3. So if I do JPS here, it shows me that data node is running. So let me do Hadoop fs-ls. Currently I do not have any data. So let me create a file, vi test file. So I write something. This is test file. So I will copy this file to Hadoop cluster, right? So we see all these commands, how we set up everything in detail in our courses, but I'm just giving you kind of a feel of Hadoop cluster. So now I say ls, so I can see the file. I can cat the file. So now I want to find where this file went in my Hadoop cluster. I can do fsck on the file. I can say files. I can say blocks. I can say locations. So it will tell me, okay, this block file went on this data node whose IP is 72. So if I come here, this is the node whose IP is 72. So this file went there. Where it went? ls-l/ wherever I will configure my store. So I can show you this file. I can simply cat this file here. This is test file. But everything is accessed by through name node. So if I go directly to the data node, I will not know that this is test. This is the contents of test file. I can although cat it directly, but to know the file test, I have to come through name node, which is this name node. So what does it mean? Let's say I shut down data node, right? Let me stop data node. I have stopped data node. Now let me see what information I can get. I'm doing an ls on test. It will give me information. Why? Because the name, who is the owner, what are the permission, what is the size, what is the timestamp, everything is sitting on name node, and name node is up. But when I try to access this file, I try to read this file, I will get an error. Why? Because the data node on which the actual contents of the file are sitting, it's not there, right? So it is saying it is not there. So if I start this back up, and I can read the file, right? So all this has lot of details. So currently you see I have changed the replication to 1. Block is replicated only once. Why this is the case? Because I have manually reduced the replication to 1. Right? Replication to 1. This is where it is defining where my name node should store data. But by default replication is 3. So we will see all these things in our class, that how all these things work, all these details, right? So I can currently I'm going on each node and stopping the cluster, but I can do stop of my entire cluster in one go. So it is going SSHing to each node, stopping my entire cluster in just one command. So I do not need to go to each machine at a time, one at a time. So because in production we will be running 1000 nodes of cluster, or maybe 3000 node cluster. So I cannot go to each node. So I will simply say stop from one machine. It will start my entire cluster. So if I do Hadoop dfs admin -report, it will start showing me what data nodes I have. So it is saying that there are 3 data nodes which are connected to it, and total storage I have, right? So 4 gig is coming from each, so approximately 12 gig total I have. So all these things we see in our course. So if you have any questions, any specific thing which you need to ask, or any specific thing you are looking for, you can go to the site. There we have our detailed course description with each and every topic, what things we will be covering. So everything will be done hands-on demo, right? Not just theory. So please feel free to visit this site and reach out with any queries at info@learntech.org, right? So please feel free to reach out. So thank you very much for attending this session, and I hope to see you soon. Thank you very much. Have a nice day. Bye bye.